Hello guys, so this is question number 8 in engineering thermodynamics that appeared in civil services mains examination in the year 2001 and it is of 20 marks. So let us read the question. The ratio of heat transfer to work transfer in the process of an air compressor that is of reciprocating type is 1 is to 4. If the compression follows PV to the power n is equals to constant, what is the value of n? Derive the equation that you use. In such a compression process, the work required is 200 kJ per kilogram and the specific heat at constant volume is 0.75 kJ per kilogram Kelvin. What rise of temperature is expected at the end of compression process? So this is basically a compression process that is undergoing in an air compression that is of a reciprocating type. So we know that we can solve it easily. The given relation is PV to the power n is equals to some constant k. Now work done is equals to integration of PdV, that comes out to be k multiplied by V to the power minus n into dV whole integration is equals to k into V to the power minus n plus 1 divided by minus n plus 1 divided by it is integrated from v1 to v2 so that we get the relation as work done is equals to p1 v1 minus p2 v2 divided by n minus 1 is equals to mr t1 minus t2 divided by n minus 1. Now from first law of engineering thermodynamics we know that dq is equals to du plus dw and q is given as mcv into t2 minus t1 plus w, as we know that for ideal gas u is equals to cv into t. Thus we can say that q is equals to minus of w multiplied by n minus gamma divided by gamma minus 1. Hence the ratio of heat transfer is equals to q divided by w is equals to minus n minus gamma divided by gamma minus 1. Since it is a ratio, we can neglect the negative sign, and while if we put the value of n while we put the value of gamma here, we can get the value of n. So we know that q upon w ratio is given as 1 by 4, which happens to be n minus 1.4 divided by 1.4 minus 1. This implies n is equals to 1.5, and work done is given as W is equals to mr multiplied by T1 minus T2 divided by n minus 1. So W by m is equals to W is equals to minus 200, that is R upon gamma minus 1 multiplied by gamma minus 1 divided by n minus 1 multiplied by T1 minus T2. Now we have the work taken here is minus 200 because it is a compression process. So work is done on the system. So minus 200 is equals to R upon gamma minus 1. This equals to 0.75 multiplied by 0.4 divided by 0.5 multiplied by T1 minus T2, and that comes out to be temperature rise comes out to be 333.33 Kelvin. So the temperature rise is asked and we have calculated 333.33 Kelvin. So the question is solved. See you next time.